Yeah, today we are going to see how to fit a Poisson distribution and to test the goodness of fit of the Poisson distribution using chi-square test. Let's start with the problem. Fit a Poisson distribution. Fit a Poisson distribution for the following data and test the goodness of fit. So here the data are x, that is 0 to 5, and the corresponding frequencies are f 142, 156, 69, 27, 5, and 1 up. First, we want to compute the mean solution. So here the solution is 2. The first step is fitting a Poisson distribution. For that we need the value of mean. So the mean is equal to sigma fx divided by sigma f. So this is equal to 0 into 142 plus 1 into 156 plus 2 into 69 plus 3 into 27 plus 4 into 5 plus 5 into 1 all divided by the sum of the frequencies, that is 142 plus 156 plus 69 plus 27 plus 5 plus 1, right? So this should be is equal to the summation of f of x, the value is 400, and the frequency value is also 400, sum of the frequencies, so which is equal to 1. So here mean is equal to 1. So we know that in Poisson distribution, mean is equal to lambda. So mean is equal to 1, which is equal to lambda. Therefore, the Poisson distribution is P of x is equal to x, will be equal to e to the power minus lambda into lambda raised to the power x by x factorial, and here x is it takes a value 0, 1, 2, 3, 4, 5, etc. So for the lambda is equal to 1, we have that is p of x is equal to x will be equal to e power minus 1 into 1 power x by x factorial. X is equal to 0, 1, 2, 3, 4, 5. Here small n is equal to 5 here. Therefore, we take the values for x is up to 5. We can simplify this. We will get 1 e power minus 1 is 1 divided by e into 1 power x is 1 divided by x factorial. So, which is equal to 1 divided by e into x factorial. X is equal to 0, 1, 2, 3, 4, 5. Now we will compute their expected frequencies. Expected frequencies is equal to capital N into P of x is equal to x. Here the capital N is nothing but the sum of the frequencies, that is sigma f, which is 400. So we'll get expected frequencies will be 400 into e power 1 by e into x factorial, so which is equal to 400 divided by e into 1 by x factorial. X is equal to 0, 1, 2, 3, 4, and 5. Now we will compute the expected frequencies for the Poisson distribution. For x is equal to 0, we will get 400 divided by e into 1 by 0 factorial, which is equal to 400 divided by e. For x is equal to 1, same thing, 400 divided by e into 1 by 1 factorial. Since 0 factorial and 1 factorial are same, therefore here also we are getting 400 by e. Next, for x is equal to 2, 400 divided by e into 1 by 2 factorial, which is equal to 400 divided by 2 times of e. Next, for x is equal to 3, 400 divided by e into 1 by 3 factorial, which is equal to 400 divided by 6e. 3 factorial value is 6. Next, for x is equal to 4, 400 divided by e into 1 by 4 factorial. The 4 factorial is 24. So 400 divided by 6 4 are 24 e. And next, the last one, for x is equal to 5, we get 400 divided by e into 1 by 5 factorial, which is equal to 400 divided by 5 factorial is 120 into e. So using the calculator, we will find the values. The corresponding expected frequencies are 147.15, and is also same 147.15 divided by 2, you will get 73.58, and then divided by 3, for this one you will get 24.5. by 3. Again, if you divide it by 4, you will get for x is equal to 4, that is 6.13. If you divide it by 5, you will get the value for x is equal to 5, that is 1.23. Next, we have to round up the values. So, for x is equal to 0, we'll round it up to 147. Again, for x is equal to 1, also the same, 147. Next, for x is equal to 2, we can down to 73.5. So, it is 74. Next, for 24.5, we can round it up again zero point 0.5. So, we will round it up to 25. Next 6.13 it is, so we will round it up to 6. Next 1.23, we will round it up to 1. So now the distribution is x is equal to 0, 1, 2, 3, 4, 5. The observed frequency is given as f 142, 156, 69, 27, 5, 1, and the computed frequencies, that is here expected frequencies are 147. Again 147, you can cross check it. If you move up, they will get 147, 147, 74, 25, 61, 74, 25, 6 and 1, and both the sums are equal to 180, and here also, sorry, 400, and here also the total sum is 400. Okay, and this is here Poisson distribution. Now we have to test the goodness of the fit using the chi-square test. For that, the expected frequencies should be, sorry, observed and expected frequency should be greater than or equal to 10. So we have to combine with the nearest frequency. So we will get 6 plus 1 is 7. Still it is less than 10. Again you combine with the nearest one. So you will get 25 plus 7 will be 30, 31, 32. So in the same way we have to combine their observed frequencies. So 25 plus 5 30 plus 1, sorry, 27 plus 5 32 plus 1 33. So now we write their observed frequencies and expected frequencies as column wise. So we'll get OI, their observed frequencies are 142, 156, 142, 156, 69, 33, 69, 33. Now their expected frequencies, their corresponding values are 147, again 147, next 74, 32, 74 and 32. Now we need to compute the chi-square value. Calculator value of chi-square, so which is equal to summation I OI minus EI the whole square divided by EI. So this should be equal to 142 minus 147 the whole square divided by 147 plus 156 minus 147 the whole square divided by 147 plus 69 minus 74 the whole square divided by 74 plus 33 minus 32 the whole square divided by 32. So 142 minus 147 will be 5 difference. So minus 5 square is 25 by 147 and then 156 to 147 the value will be 6 plus 3 9 so 81 so 9 so 9 nines are 81 so 81 by 147 plus 69 to 74 it is 5 70 74 so 5 so 5 square is 25 by 74 plus 33 minus 32 is 1 by 32 and if you compute this value it should be is equal to 1.09 1.09. Next, this is your calculated value of chi square. Next, we want to find the table value. So the TV table value of chi square under 5%. Here the degrees of freedom will be number of observed or expected frequencies. Here the number of observed or expected frequencies is it 4. We can count it. So this is the, the number of observed or the frequencies will be 4 here observed or expected frequency so it will be 4 minus 2 which is equal to chi square under 0.05 comma 2 the value is again you will get the same as in the binomial distribution it is 5.99 so now we will set the hypothesis so H naught the observed frequency are fit with the binomial distribution sorry Poisson are fit with the Poisson distribution and the H1 is the observed frequencies observed frequencies are does not fit with the Poisson distribution. So now you have to arrive at a conclusion with the help of the calculated value and the table value. Here the calculated value of chi square is equal to 1.09, right? Let's check it. Yeah, the calculated value for the chi square is 1.09, whereas the table value of chi square is 5.99 for 5% and the degrees of freedom is 2. So this is smaller. So H naught is accepted, that is the given frequencies are fit with the binomial distribution, sorry, Poisson distribution. Okay. Once again, we'll revise the thing. Uh, yeah, so we are going to see how to fit the Poisson distribution. Once after fitting the Poisson distribution, we are going to test the goodness of fit using chi-square distribution. Oh, yeah, the question is fit a Poisson distribution for the following data and test the goodness of fit. Here the x values are 0, 1, 2, 3, 4, and 5. Their corresponding frequencies are 142, 156, 69, 27, 5, and 1. So the solution consists of two parts. The first part will consist of fitting the Poisson distribution, whereas the second part is to test the goodness of fit. Okay. First, we will fit a Poisson distribution. In order to fit a Poisson distribution, we need the mean. The formula to compute the mean will be sigma fx divided by sigma f. So sigma fx is 0 into 42 plus 1 into 156 plus 2 into 69 plus 3 into 27 plus 4 into 5 plus 5 into 1 divided by the frequencies will be 142 plus 156 plus 69 plus 27 plus 5 plus 1. Here both the sums, numerator and denominators are 400. So we will get 400 by 400 which is equal to 1. Here the value of the mean is 1. So we know that in Poisson distribution, mean is equal to lambda, and so therefore lambda value will be equal to 1. So now the Poisson distribution is P of x is equal to x e power minus lambda, lambda raised to the power x divided by x factorial, where x takes a value 0, 1, 2, 3, 4, 5 up to infinity. Next, for the lambda is equal to 1, that is for our required data, P of x is equal to x is equal to e power minus 1, 1 power x by x factorial. We know that 1 power x is 1, so we will get 1 divided by e, that is e power minus 1, into 1 divided by x factorial, that is 1 divided by e into x factorial, where x takes the value 0, 1, 2, 3, 4, 5. Now we will compute the expected frequencies. So that is n into p of x is equal to x, where n denotes the sum of the frequencies. The sum of the frequencies here it is 400. So the expected frequency will be 400 into 1 divided by e into x factorial, where x will take the value 0, 1, 2, 3, 4, 5, since the small n value is equal to 5. Now we will compute the expected frequencies for each value of x. Start with the x is equal to 0. We get 400 divided by e into 1 by 0 factorial. We know that 0 factorial is 1, so we get 400 by e. So using the calculator, we get this value as 147.15, which is approximated to 147. Similarly, for x is equal to 1, we get 400 divided by e, 1 divided by 1 factorial. Here 0 factorial and 1 factorial, the values are 1. So again you will get 400 divided by E, which is equal to 147.15. So which is approximated as 147. Next, for x is equal to 2, we get 400 divided by E into 1 by 2 factorial, which is equal to 400 divided by 2E. So using calculator, we get the value as 73.58, which can be approximated to 74. Next, for x is equal to 3, we get 400 divided by E into 1 by 3 factorial. So the value of 3 factorial is 6. So we get 400 divided by 6E. So using the calculator, we get the value as 24.53, which can be approximated as 25. Since we got the decimal is zero point 0.5, which is zero point 0.5, therefore it is approximated to 25. Next, for x is equal to 4, we get 400 divided by E into 1 by 4 factorial. So 4 factorial is 24. So we get 400 divided by 24E, which is equal to 6.13, which is approximated as 6. Next, finally, for x is equal to 5, we get 400 divided by E into 1 by 5 factorial, which is equal to 400 divided by 120E, so which is equal to 1.23, which is approximated as 1. Now the required Poisson distribution as x is equal to 0, 1, 2, 3, 4, 5, and the given frequencies are 142, 156, 69, 27, 5, 1, whereas the calculated one, that is your expected frequencies, that is fitting with the Poisson distribution values are 147, 147, 74, 25, 6 and 1, and both the totals are 400, so it is tallied now. Now the second step, now we want to test the goodness of fit using chi-square distribution. So the given frequencies, we have to take it as observed frequencies, that is OI, and the frequencies which is fit with the Poisson distribution, we can take it as an expected frequencies, which is expected values for the Poisson distributions. So their observed frequencies are 142, 156, 69 and 33, and the corresponding expected frequencies are 147, 147, 74 and 32. Since in the observed and expected frequencies you have the frequency values for 4 and 5, for x is equal to 4 and 5 are 5, 1, and then for expected it will be 6, 1. Since for to apply the chi-square distribution, we need the frequencies value should be greater than or equal to 10. So we can combine the frequency with the neighbor one. So if I combine 1 with 5, we will get 6. Still it's less than 10. So again you have to club with the nearest frequency, that is 27. So we will get the value as 27 plus 5 plus 6 as 33. In the same order, we have to combine their corresponding expected frequencies in order to maintain the value of n is 4. So we will get 25 plus 6 plus 7, which is 26 plus 6, 32. So the number of observed and the number of observed and expected frequencies are same, which is equal to 4. Now we will compute the value of chi-square, that is called the calculated value of chi-square. So which is equal to summation I, OI minus I the whole square divided by EI. So we get 142 minus 147 the whole square by 147 plus 156 minus 147 the whole square by 147 plus 69 minus 74 by whole square by 74 plus 33 minus 32 the whole square by 32. So on simplification, we get 25 by 147 plus 81 by 147 plus 25 by 74 plus 1 by 32. So using the calculator, you simplify the value, and now the calculated value for the chi-square will become as 1.09. Next, we need to find a corresponding table value for the chi-square. Here, the level of significance is not yet mentioned in the question. Therefore, the default level of significance we can take it as 5.5%, which is nothing but 0.05. Next, we want to find the degrees of freedom. For that, we have to take the number of observed frequencies and expected frequencies which are taken for computing the value of I squares or count will be 4. So we can take it n is equal to 4. So we get 4 minus 2, that is the formula n minus 2. Here the formula is n minus 2. Okay. So here the n is equal to 4. So we get chi square and the 0.05 comma 4 minus 2 is 2. We get the value as 5.99. Now for the conclusion part, before that we have to set the hypothesis. H naught is the observed frequencies are fit with the Poisson distribution, and the negation of that is the observed frequencies that does not fit with the Poisson distribution. Now we are in the stage to do the conclusion part. For that we have to compare the calculated value of the chi-square and the table value of the chi-square for the level of significance 5% with the degrees of freedom 2. So here the calculated value of chi-square is 1.09, whereas the table value of chi-square for the 5% level of significance under the degrees of freedom 2 is 5.99. So it's clearly small. Here the calculated values are smaller, that is the calculated value is dominated by the table value which is 5.99. Therefore your H naught is accepted. So as per your note, the H naught is nothing but the given frequencies or the observed frequencies are perfectly fit with your Poisson distribution. Thank you.